So this video is very long overdue, and I just got back from church. We're gonna discuss the mechanism of hydrohalogenation of alkenes. Halogenation meaning that it can involve bromine or chlorine, but this time we will focus on chlorine. So, how does 2-methyl-2-propene turn into 2-chloropropane? Well, let's start from the first step, which is the formation of carbocation and halide. Looking at 2-methyl-2-propene, it consists of a double bond, and a double bond consists of a pi bond and a sigma bond. The pi bond is more loosely held than the sigma bond, so it is an electrophilic site. Nucleophilic site. Nucleophilic atoms have a lot of electrons, and it have a tendency to donate electrons. So let's say in the situation that electron is like money in the chemistry world. So we can say that this pi bond is very rich, and it has a good heart. It wants to donate to the poor. Now, let's move on to the HCl. H is a partially positive atom, while Cl is a partially negative atom. Partially positive means it has less electron and is poor, according to our example earlier. So the pi bond over here sees this very poor H atom and thinks, that poor thing, I will donate money for it. So, without thinking much, the pi bond will attack the H atom so that it can make a new bond. But what about this Cl here? So this bond over here, which is 2 electrons, will be pushed to Cl. Why Cl? Because it is more partially negative and have more strength to hold onto that electron. This reaction though will be slow because a lot of energy is needed to overcome the strength of the double bond there. So we need to write slow on the arrow of the reaction. Now, the pi bond will break and bond with the H atom to make a new bond over here, which we just put H. But since the double bond here is gone, this will form a carbocation. And do not forget about the Cl earlier. Since the electron has been pushed into it, it will become an ion, Cl minus ion. But we are not done here. We move on to the second step, which is the rapid reaction with anion. So just copy back the product from the first reaction. Very easy, very simple. So this Cl minus ion will become the new nucleophile. It also wants to donate money. It also wants to donate electron to anyone near it. So it is readily available to attack this new carbocation here. So we need to draw an arrow to indicate the attack. Since it is readily available, the reaction will be fast. So we need to write that on the arrow here. Fast. Just like that. And this will form the 2-chloropropane. But hold on. Why is the Cl there? Why not here or here or here? There's a reason for that. We want to find the major product. Right over here. Major. To determine the major product, we use the Markovnikov's rule. The definition is long and winded, but technically it will bond with the most stable carbocation. Now, we already know that the most stable carbocation out of all is the tertiary carbocation. To make it clearer over here, there's a carbon over here, carbon over here, carbon over here, and carbon over here. This carbon is a primary carbocation because it only connects to one carbon. Same as this one. This is also primary, and this is also primary. Don't make the mistake, that's only the H atom. There's no C over there. But this one is special because it is attached to three carbons. So this will be the tertiary carbocation, and thus proving that it is the most stable one out of all, and justifying why Cl would bond there. So now, the mechanism of hydrohalogenation of alkenes is done.